Good morning, students. Good morning. Welcome to my class. Today's topics ionic bonding, chapter 7. Okay, look, this is water, H2O. What type bonding here? Why this here? Two hydrogen atoms, one oxygen atoms. They are combined. These elements atoms combined form water molecule due to a attraction force, and this attraction force is called bonding. So this is bonding here. Water. These three atoms, two oxygen atoms, one hydrogen atom joined together due to a attraction force. This attraction force is called bonding. Okay, this between ionic bonding, we know so far in IGCSE level, all levels, this ordinary level, this IGCSE level, ionic bonding, there are three types bonding we will discuss three type bonding: ionic bonding, metallic covalent bonding, and metallic bonding. Ionic bonding form between metal and non-metal, and covalent bonding form between non-metal and non-metal. Yes, non-metal and non-metal. And metallic bonds form metals. In a metallic bonds, only metals are involved. In ionic bond, metal and non-metals are involved. Covalent bonding, non-metal and non-metals are involved. Okay, we'll know at first which are metals, which elements are metals. Look, these elements look at the periodic table. This red color elements are metal, and deep blue color, these are non-metals, and this yellow color, these are metalloids. They carry both characteristics of metals and non-metals, so they are metalloids. Look, metals, group 1 elements except hydrogen. Group 1 elements except hydrogen are metals: lithium, sodium, potassium, rubidium, cesium, francium. Group 2 elements all are metals: beryllium, magnesium, calcium, strontium, barium, radium. They are metals. These are D block elements, all are metals. Lanthanide series, actinide series elements are metals. Now group 3 or group 13 except beryllium, all are metals: aluminium, germanium, indium, thallium. And group 4, these are carbon is non-metals: silicon metalloids and germanium metalloids, but stannum, tin, Pb, plumbum, these are metals. Have you seen this? And group 8, all are group 0 or 8 noble gases, all are non-metals. Group 7, fluorine, chlorine, bromine, iodine are non-metals. Oxygen, group 6, oxygen, sulfur, selenium is non-metals. And group 5, nitrogen, phosphorus, non-metals. So we know this between metals bonding form. So you give me an answer this question. What type bonding contain in the molecule nitrogen? In nitrogen, what type bonding is present in nitrogen molecule? Na2.
Covalent bonding.
What?
Covalent bonding.
Covalent bonding. Good. And water. In water. In water, what type bond is present? Hello, student. In water, what type?
Covalent bonding.
Why? Why?
Sir, covalent bond.
Why, Sadman Sakib? Why it is covalent bonding is present in water? Why covalent bonding is present in water? These two elements.
Because hydrogen and oxygen are non-metals.
Oh, both are non-metals. Yes. Okay. Now sodium chloride. Sodium chloride. What type bonding is present in sodium chloride?
Ionic bonding.
Why?
Because sodium chloride is both not metals, both metals.
Sodium metals and chlorine is non-metals. Okay. Magnesium oxide here also ionic bonding because magnesium metals, oxygen non-metals, and magnesium metals. Among magnesium metals, what type bonding?
Metallic.
Metallic bondings. Okay, good. So you have to, if you want to identify compounds, either compounds or molecules, either which type bonding is present, either ionic bonding, covalent bonding, or metallic bonding, you need these things. Which are metals, which elements are non-metals. Okay, you will remember this thing. Okay, now we'll see the how ionic bonding is formed. How ionic bonding is formed. We know every elements want to become stable. They want to form the octet or noble gas electronic configuration. They want to become stable. For this reason, they lose electron or gain electrons to become stable. Like every element want to become stable. Will I use yellow color? Green color use. Green color is not clear. Should yellow. Are you watching this color, yellow color?
Yes, sir.
Blackboard is best. Blackboard is best. I should use blackboard. Okay. Now I use here, this one is blackboard. Maria joined after a long days. Yes. Okay, what thing I was going to show you? I forgot. Why do elements form bonding? Because elements want to become stable. Like sodium, they want to gain the noble gas electronic configuration. Like sodium, we know 11 atomic number 11. So sodium 11 proton number is 11. So electronic configuration is 281. 2 8 okay, 281. So it inner shell 2 electrons, then here 8 electrons, 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 and in the outermost shell in the sodium is 1 electron. So it will either lose electron or gain electron. Which is better for sodium to gain octet? Which is better for sodium to gain stable electronic configuration or
Lost electron.
yes, losing
Lost electron.
lost electron. In the outermost shell is only 1 electron, 281. It lost its last electron. It can gain easily octet. If it want to gain, it should gain 7 electrons. So gaining 7 electron is not difficult than losing 1 electron. So for this reason, sodium lost electrons, and it lost electron and become losing 1 electron, and it become positive charge. Okay, I am showing this. So one shell will remove. And what can I do? Have you seen what I am doing this thing? It will not be possible in the live class. Yes. Well, have you seen whatever I did? So it lost 1 electron and become it. Here it was 281. 281 lost 1 electron and become here 28. So it gained stable electronic configuration like noble gaseous electronic configuration gain. Okay, so sodium metals will lose electrons. Metal losing electron from ions. This by losing the charged particle is called ion, positively charged particle is called cation. So this is losing electrons from cation. Okay, now this okay, now I am doing this another elements like chlorine. Chlorine, what will do chlorine? What will do chlorine? We know chlorine electronic configuration is chlorine is electronic configuration is atomic number is 17. So 287 chlorine, 287. 287. Chlorine. So here 2 8 and now I'll give 7 here. 5 27. Okay, this 7 electron, 2 electron, 8 electron, and third shell 5 electron, 7 electron. So 287 chloride. So what will chlorine will do to gain stable electronic configuration? Will it lose electron or gain electron?
Gain electron.
Because it has already 7 electron. If it gain 1 electron, it gain octet. So it will gain electron. Now it form stable electronic configuration. Now here is a 7. Now it will become 8. Gaining 1 electron. So it more 1 electron, negative charge, more negative charge, 1 more negative charge. So 1 negative charge will be. So chloride ion is formed. So negative ion is formed. The negatively charged ion is called anion. This anion is formed. Okay, between this cation and anion, there is a strong electrostatic attraction force between cation positively charged ions and negatively charged anion is called ionic bonding. There is a strong attraction force, electrostatic attraction force between positively charged ions and negatively charged ions. This strong electrostatic attraction force between positively charged cation and anion is called ionic bonding. Here these things formed. Here sodium lost 1 electron and chlorine gain 1 electron. So sodium become positively charged ions and chlorine become chloride ion, negatively charged ion. There is a strong electrostatic attraction force between positively charged ion and negatively charged ion form ionic bonding. So the charged particles that are formed are called ions. Okay, a positive ion is called a cation, for example Na plus. A negative ion is called anion, for example chloride. Ions are charged particles formed when atoms or group of atoms lost or gain electrons. Loss can be either a positive or negative charge. Ions can have either positive or negative charge. Okay, how ions are charged particles formed when ions form charged particles when they lost electrons or gains electrons. Okay, what is ionic bonding? The strong electrostatic attraction force between positively charged ions and negatively charged ions is called bonding.